This video is for lesson 7-10 about the nature of the roots of a quadratic equation. Here we have three quadratic equations which are graphed. We know that they create parabolas, so there's three of them drawn on the same grid. The y-axis is coming down right here, and the x-axis is coming across right here, and they intersect here at the origin. We can see that the graph on the left is a parabola that touches the x-axis in two locations, here and here. It has two x-intercepts. We can see that the middle of the parabolas touches the x-axis in only one location, just past the 3, so it has one x-intercept. And we see that our third parabola is too high, so it does not touch the x-axis at all. The graph on the left is the graph of y equals x squared plus 12x plus 32. The related equation to that replaces the letter y with a 0 when it's in standard form. And that parabola, which crosses the x-axis in two different places, shows us that there are two real number roots to the equation. And we can see that here x is -8 and here x is -4. Those are the specific roots. Let's calculate what b squared minus 4ac is for this equation. Recall that a is a 1, b is 12, and c is 32. So b squared would be 144. And then minus 4 times a is 1, times c is 32. Type this in a calculator to see what this makes. It turns out to be positive 16. So the value of b squared minus 4ac for the first graph is a positive number. Now our middle graph is the parabola y equals -1/2 x squared plus square root of 10x minus 5. If you replace the letter y with a 0, that creates this standard form equation. Because the parabola touches the x-axis at only one spot, we can see from the graph there is one real number root, and specifically, it's the square root of 10. But let's not worry about what the root actually is. Let's figure out what b squared minus 4ac is. This is a, this is b, and this is c. So b squared would be the square root of 10 squared. Well, that makes a regular 10. The letter a is -1/2, and letter c is -5. Let's take a calculator and figure out what that makes. This turns out to be 0. That's interesting. When b squared minus 4ac is equal to 0, there's one real root. But last time, when b squared minus 4ac made a positive number, there were two real roots. Let's consider one more example situation. Let's take a look at this equation. The value of a is 1, b is -14, and c is 53. Let's figure out b squared minus 4ac. So b squared would be -14 squared. On a calculator, that's 196. And then minus 4 times 1 times 53. When I type this in a calculator, I get the result -16. The b squared minus 4ac makes a negative number. And when that happens, there are no real number roots. The parabola does not intercept the x-axis. Let's consider those three results and kind of summarize what we noticed. First of all, let's give a vocabulary name to the expression b squared minus 4ac, which I hope that you recognize is the thing inside the radical in the quadratic formula. We call that the discriminant because it discriminates between three different cases. Another word for discriminates is it distinguishes between three different cases. An equation that has two real roots, one real root, or no real number roots. When the discriminant is greater than 0, there are two real number answers. When the discriminant equals 0, how many are there? There's 1. When the discriminant is a number less than 0, how many real number answers are there? There are 0. There are still answers, but they're called imaginary roots, and we'll learn about those in chapter 10. The discriminant can also be used to distinguish between rational number roots and irrationals. Remember, rational numbers are any numbers that can be written as fractions. Irrationals are the ones that can't be written as fractions. They have a radical sign, such as the square root of 2, the square root of 5, and so on. Those are called irrational numbers. Here's how to use the discriminant to tell if roots are rational or irrational. If a quadratic equation that has rational coefficients has rational roots, then that will only happen if the discriminant is the square of a rational number. Like if the discriminant turns out to be positive 16, that is the square of a rational number because 16 is 4 squared. Or if the discriminant turned out to be 25, then there are rational roots because 25 is the square of a rational number. It is 5 squared. But if the discriminant turned out to be 17, then there are irrational roots because 17 is not the square of a rational number. Let's do an example problem and determine the nature of the real roots of this equation. So when it says determine the nature, what it's asking us is, are the roots going to be rational or irrational? Let's use this theorem that I marked with the star right here. We find the discriminant, b squared minus 4ac. B squared will be 16. A is 2, and C is negative 3. Figure out what this makes. Use a calculator if you need to. This is positive 40. Is 40 the square of a rational number? No, it's not. If you tried to take the square root of 40, you would get a weird decimal. So our roots are irrational. The next concept that this lesson is going to talk about is what the zero of a function is. It's any value of x in the function which satisfies the equation f of x equals 0. Zeros of a function, or roots of an equation, or x-intercepts all mean the same thing. If you want to solve an equation for x, that is the same thing as finding zeros of a function. That is the same thing as finding x-intercepts of a graph. Let's do an example problem. Determine the nature of the zeros. So this thing is asking us about the nature. Is it asking us to solve for them? No, it's not. We just want to figure out the nature. So we're going to use the discriminant, not the complete quadratic formula. So for the letter B, fill in the negative 4 square root of 3. For the letter A, fill in 1. And for the letter C, fill in 12. And then evaluate this. Negative 4 squared is 16. Square root of 3 squared is 3. And 16 times 3 makes 48. And then 4 times 1 times 12 is 48. This makes 0. Remember our 3 cases. When the discriminant is 0, what did that tell us about the roots? We have one real root. Then, because it's a real number root, we can also figure out if it's rational or irrational. Because one of the coefficients is an irrational number, we can tell that our one real root is irrational. Let's summarize the lesson. In this lesson, we did not use the complete quadratic formula to actually find roots of an equation. Instead, we used just part of it, the b squared minus 4ac, which is the thing under the radical. And by evaluating that, which is called the discriminant, we can decide if our equation will have 2 real answers, 1 real answer, or no real answers. And we're also able to use the discriminant to see if any real number answers are rational or irrational.